How are you? Today online class, we got you.
Good day, everyone. Once again, you are welcome to Today online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the bottom. Good day, viewers all over the world. You are welcome to Toydel online class. So today we want to look at limits of a function. The limit of a function will actually help us to develop the concept of calculus. So the limit of a function is an important concept that will help us to develop the concept of calculus. The concept of the limit of a function is one of the most important ideas of calculus. That is, how do we take a limit of a function? Now, say suppose that f is a function of x, such that f of x is equal to, let's say, 3x squared minus 5x minus 2 all over x minus 2. Suppose we have what we have there on the board. Suppose we have what we have on the board. F is a function of x. So, of course, y is a function of x. So f of x, where we have f of x is y. So y is dependent variable, yx is independent variable. So we can get the value of x without knowing the value of y, but we can never get the value of f of x, which is y, without knowing the value of x. So what is the value of y? When we say maybe when x near 2, that is what's the value of y when n is equal to 2. So how do we take that? Then we talk about the limit of a function. So what do we do? So x can approach 2 either from the left or from the right. That is, if this is 2. If x approaches 2 from the right, we are going to have something like 1.99. If x approaches 2 from the right, this from the left, we have something like 2.001, 2.000 something. So limit simply means when it tends to 2, not exactly 2. So when we talk about limit of a function, we say as x tends to, not exactly that value, but it tends to. So there are two things to check here. That is, if we want to find the value of y when x approaches 2, what do we do? You realize that the value will varies as x approaches either from the positive side or from the negative side. So this what do we do? Then this is what we do. We just say limit of f of x as x tends to 2. Of course, we can generate a table. Just say when x, we generate a table that when x is equal x and f of x. So we test for when x is equal to 1, maybe 1.5, 1.75, and we can test for 1.999. We do that. We can test for that. Then we can also generate a table. This is ascending order. We can generate a table for descending order. That is when we have x and f of x. That is x will start from 3, say 2.5, 2.5. When we have 2.0001, at the end of the day, we realize that by the time we get to something like 1.999 and 2.000, the value of f of x will be almost the same. We have something like 7.003 here. Then we have something like 6.9999 here. So both value at this point will be approximately 7, will be the same thing. So the implication of this is that we not write it this way. That is, we say limit as f of x, limit of f of x, limit as x tends to 2 of f of x will not give us, that is, this will give us what we are about to write now. That is, we substitute for when x tends to 2, not exactly 2, but it's closer to 2. That will be 3 into bracket 2 squared minus 5 into bracket 2 minus 2 all over, this will be all over 2 minus 2. So you know when we do what we do here, this will be undefined because denominator is x minus 2, because 2 minus 2 will be 0. Then once we have 0 at the denominator, what happened? Once we have 0 at the denominator, this fraction will be undefined. Here we are going to have 2 times 2, 4, 4 times 3, 12. Here will be 12 minus 5 times 2, that's 10, minus 10, minus 2. At the end of the day, we have minus 12 minus 12 all over 2 minus 2, and that will be 0. So limit as f of x tends to 0 from what you have there can actually be 0 if it's substitute directly. So the concept of limit of a function is somehow tedious, but the following theorems will actually help us to be able to find the limits of a function. The following theorems will help us. That is theorem. If the limit as x tends to a, f of x is equal to f, and the limit as x tends to a, g of x is equal to g, then the first one, we have that the limit as x tends to a, f of x plus g of x will give us f plus g. That is, if we define the limit as x tends to a, f of x as f, and the limit as x tends to a, g of x as g, then the limit when we have addition will just be f plus g. The second one, when we have subtraction, it will be f minus g. So it's plus or minus. That will give us that. If it's plus or minus, we are going to get what we have on the board. If plus or minus, we get what we have. Then the third one, when we have the limit as x tends to a, then if we have f of x multiplied by g of x, this will just give us f dot g. Of course, dots connote multiplication. Then the third one, which happen to be the fourth one, when we have limit as x tends to a, f of x divided by g of x will give us f all over g. Okay, provided that g is not equal to 0. Like the example I gave, when we have f of x, when we substitute directly, you realize that we got 0 as our final answer. So when we have the limit as x tends to a, and if the function is in form of division, if we substitute directly and get 0, so there are processes that will follow. So by the time I give example, I'll be able to expatiate further. So just take note of this theorem for now. By the time I give example, you will know what to do here. Like the example I gave the other time that we got 0, we know how to proceed. If you want to do that, is either you factorize the equation, you factorize both the numerator and denominator before you substitute the value, or you use what is called the L'Hopital rule. So by the time I give, so let's give examples on limit of a function. When it is addition, when it is subtraction, when it is multiplication, and division. So limit of a function is the first concept that we discuss before we go into calculus generally. And of course, when we talk about calculus, we are talking about differentiation and integration. So before we talk about calculus generally, there's need for us to understand the concept of the limits of a function. So example, let's call this example 1. Evaluate the following limits. So the first one, limit as x tends to 5, 3x minus 7. Then B, let's take this first 2 questions. Limit as x tends to 2, x squared plus 2x minus 1. So solution. In this case now is where we have addition and subtraction. Of course, it's very simple. Just go ahead and substitute directly. That is, when we have limit as x tends to 5, 3x minus 7. So what do we do here? We just, we can split it and say limit as x tends to 5, as x tends to 5, then we have 3x minus limit as x tends to 5, 7. Of course, this is a constant, so we don't need this. So this is going to give us, once you substitute for x, you remove this limit there. You now say 3 times 5 minus, here will just be 7. Here will be 7 because we don't need that. That will be 15 minus 7, and that's going to give us 8. So the value will be 8. So in case of addition and subtraction, we don't really have much problem. The second one is when we have limit as x tends to 2, then we have x squared plus 2x plus 1, no, minus 1. So what the limit will be, the limit of this is going to give us, I don't need to, I can just substitute directly. Once I substitute for x, I won't put this limit again. I'm going to have 2 squared plus 2 into bracket 2 minus 1. That will be 4 plus 4 minus 1. And that's going to give us 7. That will be 7. So let's take another example. Say example 2. A, then B. So let's take another example. Example 2. We have to find the limit when limit as x tends to 2, we have x minus 2 all over x squared minus 4. Then C, we have limit as x tends to A, we have x squared minus a squared all over x minus a. So in this case now, look at question example 2, A and B, solution. In this A now, we have limit as x tends to 2, x minus 2 all over x squared minus 4. So if we substitute for the value of x directly, you realize that we are going to get 0. That is, if we substitute for, just like the example I gave, when we substitute directly, you realize that we got 0 as the limit, which is wrong. So if we substitute directly here, 2 minus 2 will be 0. 2 square, that is 4. 4 minus 4 will be 0. So once, if you have the limit, when it is fractional, then when you substitute directly, we are going to get 0. Then the next thing, once you get 0, you can go ahead and simplify. That is, you factorize either the numerator or the denominator. This is x minus 2. Then x square minus 4 is same thing as 2 square minus, that's same thing as x square minus 2 square, difference of 2 square. So that will be x minus 2 into bracket x plus 2. So this is what you are expected to do. So that this will take care of this. At the end of the day, we now have limits as x tends to 2, 1 all over x plus 2. That is when you substitute, you are going to get 1 all over 2 plus 2. And that will be 1 all over 4. That is what is expected. So if you don't want to factorize, or if the concept that we have is difficult to factorize, maybe that they are not factorizable, then you go ahead and use what is called the L'Hopital rule. So if you don't want to use this method, you use L'Hopital rule. L'Hopital is spelled as Hopital. L'Hopital's rule. L'Hopital rule simply means that you differentiate both the numerator and the denominator. But because I've not introduced the concept of differentiation here, but I will differentiate now. But with time, you understand how to differentiate. So that's the meaning of L'Hopital rule. L'Hopital rule simply means you differentiate both the numerator. That the simplest explanation on this L'Hopital rule simply means that you differentiate both the numerator and the denominator. So instead, at the end of the day, we are going to get 1 over 4. So let's quickly do that. Is that you use that first method, or you want to apply L'Hopital rule now? So it says that limit as x tends to 2. When I differentiate the numerator, I'm going to get 1. Differentiation of this is 1. Then when I differentiate the denominator, I'm going to get 2x. Differentiation of constant is 0. Just let's take it for now. But after this, I'm going to introduce differentiation. Then we'll know how to differentiate. So from this point now, we now substitute as x tends to 2. We have 1 over 2 times 2. And that's same thing as 1 over 4. So when you want to take the limit of a function that is fractional, if you substitute directly and it's got to 0, go ahead and factorize. If what you are given, the expression is factorizable. And if it's not factorizable, just go ahead and use L'Hopital rule. That is, you differentiate both the numerator and the denominator before you substitute for the value of x. So we go ahead and solve the second example under example 2b, where we have limit as x tends to a. Of course, if you substitute directly also here, you are going to get 0. You are going to get 0. So don't learn. So what is expected is that we can factorize this. The numerator is factorizable. It's different of 2 square. You are going to have x minus a into bracket x plus a all over x minus a. So x minus a, we cancel this. Then at the end of the day, we have limit x tends to a, x plus a all over 1. So we substitute that we are going to get a plus a all over 1, and that's going to give us 2a. It's going to give us 2a at the end of the day. So we take example 3. We go ahead and take example 3. So let's take example 3. In this example 3 now, we have this is another form. Example 3, we have limit as x tends to infinity. When x tends to infinity, what are we going to do? 4x minus 3 all over 2x plus 2. Then let's take another one. We have limit as x tends to infinity, 7x squared minus 2x plus 1 all over 3x squared plus 8x plus 5. So what do we do here? Whenever x tends to infinity, then it is expected, this is what we are expected to do. A, limit as x tends to infinity, 4x minus 3 all over 2x plus 2. So if you have this type of problem, this is what we are expected to do. Just look for the highest coefficient to divide through. In this case now, the highest coefficient, the highest coefficient here is x. The highest look for the value of x. Maybe we have x squared. This is a linear. The numerator is linear. The denominator is also linear. So we divide through by x. We are going to divide through by x. In this second example now, here we have quadratic x squared. So we divide through by x squared here. So if we do that here, we say limit as x tends to infinity. So we now divide 4x divided by x minus 3 divided by x all over 2x divided by x plus 2 divided by x. So that is what we do. So if you're able to do that, then of course, x we cancel x, we are going to get 4, x we cancel x. So that's what we get. Then this is what you do. Since we have limits as x tends to infinity, so if x is divided by infinity, infinity is very large. So 3 divided by infinity will be 0. Here is going to give us 0. This other one will also give us 0. At the end of the day, x cancel x, we are going to have 4 at the numerator, then all over 2, because this will be 0, this will be 0. So the final answer will now be 2. That is what we are going to get. So we go ahead and solve for the next one, where we have limit as x tends to infinity. Whenever we have as x tends to infinity, you are expected to divide with depending on the nature. If this x cube, you use x cube to divide all through. In this case now we have 7 squares. X square is the highest, so we are going to use x square to divide all through. So we have 3x squared plus 8x plus 5. So here we are going to have limit as x tends to infinity. So we have 7x squared all over x squared minus 2x all over x squared plus 1 all over x squared all over 3x squared all over x squared plus 8x all over x squared plus 5 all over x squared. So now, when x tends to infinity, this of course 7x squared, we can't 7x squared here. So we only have 7 here. This will reduce it to 1. We still have x here. So when x tends to infinity, infinity is a very large number. So when we say 2 divided by, say just like we say 2 divided by 1 million, you are going to get 0.0, something that is not, you have something that is not relevant, that is not significant. So we are going to have something like 0. It will be approximately 0. Then in this case also it will be 0. Okay, all over this will take care of this. We are going to have 3. So x will reduce this to 1 all over x out there. So if x tends to 0, just like when we say 8 divided by 1 billion, it will be 0.00. So it will be something that is insignificant. So this will just be 0, 0. At the end of the day, the answer will be 7 all over 3. So the limit as x tends to infinity will be 0. It will be 7 all over 3 as a final answer. Then let's take the final example. Evaluate. So evaluate limit as x tends to minus 3, x squared minus 9 all over x plus 3. So in this case now, what do you do? I said when it is fractional. When it tends to infinity, you know what to do. Just divide by this one is x tends to infinity. just divide all through by x squared. So the one that has x at the denominator will tend to 0. Give me minus 6. So this is going to give me minus 6. So or if since we have not discussed this calculus, I will factorize the numerator, limit as x tends to minus 3. Then if I factorize the numerator, difference of 2 squared, that will be x minus 9. That will be x minus 3 into bracket x plus 3 all over s plus 3. So s plus 3 becomes s plus 3. At the end of the day, I will have limits as x tends to minus 3, x minus 3. So when I substitute, that will be minus 3 minus 3, and that will give me minus 6. So that is what you are expected to do. Since we have not done calculus now, you may not really understand how to differentiate here. So when we use L'Hopital, it simply means you differentiate the numerator and the denominator. Okay? Or if what you have can be factorized, if they are factorized, we just factorize and cancel out. So that is what is expected of you. So I would love to stop here because of our time. So if you have further example on limit of a function, just write it at the comment section. So I promise to attend to it.
Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need.